okay, in the southern region of Austria. So if you ever have the chance, or I'm not sure if you've been to Austria already, but you should definitely visit Graz, which is with a good climate and a nice hill in the middle of the city center. So you can walk up here and see the clock tower, which is more or less one of our landmarks. And yeah, so, and I visited Bristol in 2020 to start this project, although then moved back to Austria and back to Bristol again and so on. So I'm quite happy to present this project here in your session. Okay, let's go back to physical activity. I think we all know that physical activity is very important for our health, and we have strong and very good evidence, good quality evidence for different health outcomes. And we often see a dose-response relationship between physical activity and health, like the one seen or shown here on the right side. So you can see that the benefits are usually the greatest for people who are very inactive and start to move a bit more. So then you can gain a lot out of physical activity. Then it flattens out a bit and maybe increases in the end, could increase. And physical activity itself is quite complex with different dimensions, domains, and bout durations or parameters of physical activity. And today I would like to focus on the intensity of physical activity. And we often see those terms of sedentary, light, moderate, and vigorous physical activity in the literature. Measuring physical activity, we can use different tools. So I did my PhD in physical activity measurement, but focusing on self-reports, so questionnaires, diaries, and so on. But especially in the last 10, 15, a bit longer years, we start more and more using different devices to measure physical activity in free living environments, like accelerometers or pedometers. So we could ask people to wear those devices a couple of days and to use the information or the acceleration collected to get an idea about the frequency, duration, and intensity of physical activity. And today we focus on accelerometry. We can analyze activity counts or even the raw units behind that. So activity counts is kind of a already calculated or a transformed metric out of the raw data collected. And we usually average this information over a specific time period, like 5 seconds or 1 minute, for example. So we could end up with count information for each minute of measurement throughout the entire week. And higher counts means that we had higher acceleration going on, which we assume was due to more physical activity. We use this activity counts or raw units information to classify each time interval to different intensity levels. Like we have seen on the slide before, sedentary, light, moderate, and vigorous physical activity are classified using cut points for those count information. For example, if a minute had less than 100 counts, we would assume that this minute was rather sedentary or inactive, and so on for the other categories. But the problem is that we often, or also especially in the past, we only used a few and broad intensity categories. So we often combined moderate and vigorous physical activity to have MVPA. So we heavily depend on cut points, on specific single cut points. And that also means that we collapsed many different movements into one group. So for example, if you think of playing squash or brisk walking, they are quite different, but are collapsed into the same group of MVPA. And we often, another consequence is that we lose a lot of useful information if we only look at the high intensity part, but do not consider light physical activity, for example. And focusing on only a few categories also means that it's difficult, or we do not really assess the relative importance of specific intensities. But the problem, or perhaps also the reason behind that, is that we have closure and multicollinearity between the physical activity variables. So time spent in different intensities like light or moderate physical activity is correlated to each other, especially information or time in intensity neighbors. And we have the closure issue or aspect that it always sums up to 24 hours. So if we have 1 hour more of light physical activity, we need to have 1 hour less somewhere else. So we get a lot of, because of those issues, we get a lot of statistical problems. And there are recently, especially during the last 3, 4, 5 years, I would say, newly introduced or adopted statistical strategies to handle or tackle these problems, and to look at physical activity from a different perspective, from a multivariate and interdependent perspective, I would say, rather than focusing on single categories or unique contributions and so on. And one of these approaches is multivariate pattern analysis, which is essentially PLS, partial least squares regression. And this method is also used in a lot of other disciplines, but was introduced to physical activity research around 3.5 years ago. And the advantage of this method is that it makes no assumptions regarding the distribution and correlation between the predictors. So it allows to include collinear or correlated predictors and even outcomes. And it tackles the issue of collinearity with latent variable modeling. What is PLS doing? It's more or less a combination of principal component analysis and regression, while maximizing at the same time the covariance with the outcomes. So it tries to use this or creates independent components of the predictors of, let's say, our intensity information of physical activity, and maximizing the covariance with the outcome at the same time. And PLS treats all the intensity information together at the same time. So we are now talking about association patterns in the multivariate space, rather than trying, as I said before, looking at those individual variables or intensity categories and their unique contribution. So that is one method which tries to tackle the collinearity and closure issue. And I can show you one result of this method. And when this method was first introduced and applied to metabolic health in children. So here you can see a plot showing the link between the intensity of physical activity from 0 counts to more than 8,000 counts per minute. And here on the other axis, you can see the selectivity ratio plot, which is basically a measure or indicator of effect size, showing the ratio of explained to unexplained variance, giving us an idea about the relative importance of specific intensities. And what the Norwegian group who introduced this method found or saw that overall the association was with metabolic health was much higher, around 13%, when using all the intensity information together, compared to only using moderate to vigorous physical activity, for example, everything above here. And what the results also tell us, or what showed us, is that most of the association is due to time spent in higher intensities. And not much is going on with time spent in sedentary activities or even light physical activity. So the strongest association can be seen here, even with a very vigorous intensity. So that was kind of the first studies who applied this method to metabolic health. But PLS was or has not really been applied to other outcomes such as mental health. So, and that was the idea of this project. So we wanted to use PLS to explore the associations between the intensity, physical activity intensity in early adolescence at age 14, and anxiety and depressive symptoms in adolescence, same age 14, so cross-sectionally, but also into adulthood. So we had the idea to look also at the relevance of the overall intensity information. We wanted to identify specific intensities which are relatively strong associated with mental health. And we wanted to investigate differences in the pattern between different mental health outcomes. So those were the ideas of this project. We used data from the ALSPAC study. We reprocessed the ACTI graph files, the physical activity data, which was collected at age 14, to derive this intensity spectrum, so the multiple smaller intensity information. And we used mental health outcomes from continuous outcomes, or continuous scores from 2 different measures, from the short mood and feelings questionnaire and the revised clinical interview schedule. And on the next slides, I will show you a few results showing fully adjusted models, similar graphs as before. And perhaps I forgot to mention another advantage of this tool, as you can see here, is using this multiple smaller intensity information or intervals. So we do not so much rely on single cut points compared to if we use one cut point and then assume that everything above is moderate to vigorous physical activity, for example. So that's another advantage, that we can use smaller intervals. So this is the association between physical activity and depressive symptoms at age 14, so cross-sectional association. Selectivity ratio is in this plot showing us the explained variance of the total variance of the predicted outcome. And we can see that overall physical activity and also sedentary time or inactivity is linked to depressive symptoms. But we can see some peaks here and also here, which means that those categories or time spent in this intensity intervals is stronger, let's say a bit stronger, associated with depressive symptoms. When we go to age 18, looking again at depressive symptoms, but this time from the CISR, from the computerized interview, we can see a fairly similar pattern, indicating the overall association. If we go to anxiety at age 18, so between physical activity age 14 and anxiety at age 18, we also see a fairly similar pattern, perhaps a bit less a relationship with the higher intensity information here. If we look at the multiple SMFQ measurements, so that's just one analysis using the median values between age 16 and 25, we lose a lot of participants, but we get a similar pattern, even though not much information or overlap is seen for the higher intensity part. Okay, I think I'm already at the conclusions. So this results, or the first results, showed us that the intensity spectrum is associated with mental health outcomes, both cross-sectionally and longitudinally. But the association overall is very weak. So I did not tell you this before on the few slides. So if you remember, the association with metabolic health was around 13%. But in our analysis, we have overall R squares of around 1 or 2%. So which is very low compared. But the models were significant and stable, but we have to admit that the association overall is actually very weak. But we have seen relatively that both sedentary time and physical activity act together. They're both relevant or associated with these mental health outcomes, and especially perhaps of moderate intensity, time spent in this intense intervals. And we've also seen that the pattern is fairly similar between different mental health outcomes, even though compared, for example, to the pattern observed for metabolic health. We saw that also moderate or light physical activity is important, whereas for metabolic health, the other studies showed us that it's rather the high intensity part, and even perhaps not so much sedentary. Good. What is next? Even though we are still working on this project, we started a new one looking at different health outcomes at age 18 and 25. And the idea is to include other physical activity exposure measurements as well. So not only age 14, but rather also age 12 and 16 to have a more robust and stable, reliable indicator of adolescents' physical activity levels. Okay, thank you very much. I'm already finished with the talk. I hope it's
Thank you very much, Matteo. That was really, really interesting. Do you have any questions? Any online?
I don't know anything about this really, so it's just a general question. But it was about the graphs, and it kind of looks like the selectivity ratio goes like up and back down again. So I wondered what that was about 5 years ago.
Mm-hmm.
Yeah.
So that's just the way how we plot it. So that means a positive or negative association. Sorry, I did not really explain that, even though it's quite important. So this means that the more time you spend at this intensity, so rather sedentary, the higher the anxiety score was. And the reverse is true for this intervals here. So it's just different a way of showing it as positive or negative.
So any level of physical activity is good.
Yeah, exactly. So it's if you have more time here, you have a lower score, sum score in the anxiety subscales. Even though this area here is probably more related to the sum score compared to this one. But we also I think it's important to mention that we often do not have much information here as well. And we use a very specific technique to a specific device for collecting the physical activity data, and that provides us only information for every minute. So we lose a lot of physical activity information if we average through a longer time period compared to using, for example, averages of over 10 or 15 seconds. Because children are sometimes only active less than a minute, and this information is lost if you only use. So perhaps that's one explanation why we have more explained variance here in this area.
I saw we had a hand raised from Chloe. So Chloe, if you want to unmute and ask the question.
Hi, yeah, thank you for the talk. It was really interesting. I think you might have already mentioned this in one of your later slides, but I was just wondering if you had looked at the relationship with physical activity with individuals' symptoms of depression, or like psychological versus maybe somatic symptoms, see if there's a difference there.
So what we've done is only to combine those subscales from the interview, which is depression, depressive thoughts, I think, sleep problems, and fatigue. So it's rather psychological perceived symptoms. And the SMFQ, I think it's so the short moods and feelings questionnaire, asks about feelings, moods during the last 2 weeks or so, if I remember it correctly. So I did not split up or looked at any other differences between different symptoms or somatic or so, unfortunately.
I was just wondering as well, with the future work, are you going to include any like biological measures or anything like that as well?
So the idea is to have also, for example, respiratory health, cardiovascular health, a few blood pressure measurements, blood measurements, and fat mass, for example, from the DXA scans. So we wanted to look also on different outcomes. Yeah, so that's the idea, and then to compare the pattern.
I was just really, sorry, this is just because I'm quite interested in, so are you going to include any like markers like inflammation or anything like that?
So we have, I'm not sure which blood parameters we in the end requested from the ALSPAC cohort, but I think we might have an inflammation indicator as well. Yeah.
Thank you.
Perhaps like CRP levels or so on. So I'm not quite sure.
Thank you very much. Any further questions? Well, I think if that's it, I'd like to just say thank you very much, Matteo. That was really interesting. And yeah, thank you.
Thank you too.
Thanks for a really great talk, Matteo. Thanks for coming.
Thank you.
Really interesting. See everyone. Have a good weekend, everyone, and we'll see you all next week, hopefully. Take care. Bye-bye. Thanks again.